Alright, before we get to example 3, on the bottom of page 741, we have this box, but I'm going to rewrite it for you how it is on your formula sheet. On your formula sheet, you have the following in blue. Tk plus 1 is n choose k, a to the n minus k, b to the k. What they don't give you on your formula sheet is the following. This is what you have to know, that the blue formula works for a plus b to the n. In the textbook, they use x plus y. On your formula sheet, they use a plus b. I think by now in grade 12, you're able to change letters around a little bit, okay? The textbook formula is a little bit different, and they use k minus 1, and the formula sheet uses k. I think the formula sheet is a little bit easier to use because you have a lot less minus 1s to deal with. So everywhere, if I highlight it here, like they have a k minus 1, they have a k minus 1 there, and a k minus 1. Can you see in the formula sheet 1, those have just been replaced with k. As a result, though, on the formula sheet, we have k plus 1 here, and in the textbook, they just say k. Here's the idea. If you want to find a specific term in the expansion, for example, in the question that we're about to do, and I'm going to take this, I'm going to steal, this is so nice, steal all of this. I'm going to go to our example. Paste it again. We want to find the 9th term. So when they're talking about 9th term in notation, just like in arithmetic and geometric sequences that you did in grade 11, do you remember writing t with a little 9 to represent that's term 9? Okay? First of all, can you see that there's going to be 11 terms? This would be a little bit annoying with Pascal's triangle, because you would have to write out a lot of Pascal's triangle before you got to the row with 11 things. And you'd have to hope that your mental math doesn't screw you up along the way. Okay? But in that one with 11 terms, it's going to look like this. It's going to be 1. It's going to have a 10 for 10 choose 1. It's going to have a 45 for 10 choose 2. And it's going to keep going until there were all 11 of them. What the formula says if I want to find term 9, does it make sense that k would have to be 8 if I wanted to find term 9? Because the formula said term k plus 1. You want to find term 9? The only way k plus 1 equals 9 is if k is 8. Some very advanced math. If you need help with that, come at lunch. I can show you how that works. But, okay. So k has to be 8 to get term 9. And then everything else in the formula comes from the purple part, which isn't given on your formula sheet. You have to know that the n in the formula is the exponent. What is the exponent in our equation? A 10. Choose k. Well, we already figured out that if you want to find the 9th term, k is 1 less. It's going to be 8. Bracket. A is your first term. What is the first term in ours? An x. 10 minus 8. And the b, what's the b in ours? The second term. If there's a subtraction, you keep the negative with the number. So our b would be negative 2 to the k. Oops, that's not an 8. There we go. In order not to make mistakes, do each of these things separately first. So go to your calculator. What is 10 choose 8? Put it in brackets. 10 choose 8. That's going to be 45. Okay? You see that this is going to be x squared. Put it in brackets. Simplify it. It's just going to be x squared. Anybody know their powers of 2 very well? What's 2 to the power 8? It'll be positive because to the power of 8, the negative will be positive. 256. And now that you've done each one separately, now we can put things together. You see that we could multiply 45 times 256 and get 11,520, and you still have the x squared. This will be term 9. We can write term 9 all the way along to it. There we go. There's our term 9. This is much faster than actually finding all 11 terms, simplifying all 11, and once they're all simplified, going, okay, which one's the 9th one? 1, 2, 3, 4, 5, 6. Circle the 9th one, and you're done. You can do that. It just takes a long time. So once we get to bigger ones, they're like, can you find a specific one? And if you can find term 9, we're pretty certain you could have also found term 8, term 7. You could use this formula to find all 11 of them. You could find term 1, term 2, term 3, term 4, all the way up to term 11 if you wanted to. Again, it's just time consuming, but it's the same thing over and over again. So when the numbers are smaller, sometimes they say expand completely. When the numbers are bigger, they'll say, can you find a specific one? And in this case, the 9th term. And if you can, perfect, no problem. And the questions you can do for practice on this are 5 and 11. But we are going to do some more advanced questions as well. So I'm gonna label this as the more difficult kind of questions. You can, where do we, I think you have a blank page, 751. Okay. Now you can actually, I don't know how much we're going to do, maybe start on 750 already on that column and then continue on 751. Okay? So first of all, what are some things that end up making these questions a little bit more difficult? Because for the most part, once you get familiar with the formula and familiar with Pascal's triangle, these are very predictable and easy questions. Because you're just plugging things into the formula. Take your time to not make mental math or order of operations mistakes. You're going to do very well on these kind of questions. But you do have to practice to get familiar with the formula and how to use it. What are some questions that end up being a little bit more difficult? This is the easiest of the difficult ones. If they say find the last term, and I give you some like 3x minus 2, that's not a 2, we'll make it an 8, minus 8y to the 13. Which term is the last one? You would have to find term 14. So it requires that you know how many terms there are. And as soon as that happens, and you're like, I have to find term 14, then this is exactly like question number 3. Because it's like, find term 9, okay, I just use my formula. If it says find the last term, you have to do a little bit of thinking, like, how many terms are there? Oh, one more than the exponent. So I have to find term 14. So it's a little bit more difficult because you have to use a little bit more knowledge. A little bit more difficult than the last term. Sometimes they say, can you find the one in the middle? A little bit trickier. Which is the one in the middle? It's going to be term 4. Because the 6 tells you there's 7 numbers. Right? Number 1 mistake students do in this one for the middle, do you see them doing term 3 because they just take 6 and divide it by 2? But term 3 means that there would be 2 on this. Oh, I shouldn't use 3. Okay, don't visualize this too much. There'd be going to be 2 on this side, and of the 7, there's going to be 4 on this side. Okay? That isn't right in the middle. But if I use term 4, right, if you imagine all 7 terms, 2, 3, 4, 5, 6, 7, there's 3 on this side, 3 on this side. Term 4 is the one in the middle. Does it make sense that only if you have an odd number of terms will you have a middle one? If it was a 5, there would be no middle term. Because then there's 6 terms, there's 3 on this side, 3 on this side. In the middle, there's nothing perfectly in the middle. There wouldn't be a question. Only if you have an odd number of terms will they ask you the middle. Okay? The next level of more difficult, and we'll actually do some examples, have the following language. Term containing, and now we'll do some examples with this. Find the term containing an x to the 9 in the expansion of, and I'll give you, we'll do 3x squared find a term containing an x to the 9 in the expansion of 3x squared minus 2x. 2 over x to the 9. First of all, can you see that there's going to be 10 terms? Option 1 is the long option. Some people like this because they forget the shortcut. Does that ever happen to you? You forget how to do something, and then your other option is the very long way, is figure everything out. You could find all 10 terms, simplify all 10, and then one of them has x to the 9 in it, and you circle it, and you're done. The problem with that is that it takes too long. You would like to do less work. You guys are normal human beings. As human beings, we always choose, what's less work for me? What can I do to make this quicker? Okay, so what we do is we look at the formula. Here's our formula, I'll write it out. Tk plus 1 is n choose k, a to the n minus k, b to the k. And the problem is, we don't know, here I'll even write it out. We don't know which term it is. We don't know what k is. So what we do is we go to our formula and we write out everything we do know. We do know that when we find this term, it's going to have an x to the 9. It's probably going to have a number in front. I'm going to just put a space there because I don't know what that number is. On the right-hand side, I know that n is 9, but I don't know what k is. I know that a is 3x squared, I know that n is 9, but I don't know what k is. And I know that b is minus 2 over x, but I don't know what k is. So I write out everything in the formula that I do know. And my only hint in the question was they told me it has an x to the 9. So I'm going to use that hint, and I'm going to think, I'll write this in green. I'm going to think only about the exponents of x, and as a result, I'm going to ignore all the numbers in front, which are called coefficients. Because I don't know the number in front, so I'm like, well, that's not a good hint. I'm just going to use the exponents. So if I just use the exponents, on the left, all I have is an x to the 9. Can you see that the 9 choose k would be a number? And that would be a number in front. The 3, which is going to go to the exponent of whatever this is going to be a number. I'm going to ignore that as well. But can you see that I would have x squared to the 9 minus k? That would be all exponents of x's. And in my second term, I have x's in my denominator. Can you see that you would have an x to the k in your denominator from that second term? I ignored the minus 2 to the k, because won't that just be a number? And that number would be the thing in front. So we ignore everything that's going to be the numbers in front. We're only going to use the hint of the exponent to figure things out. Using your exponent laws, you can now solve for k. Some students like to just, at this point, guess and check. Plug in a number for k, see how close you get. Okay, pick a random number. It's going to be like, there's only, how many terms did we say? 11? So don't pick 3,000. But that's not going to be a possibility. There's going to be no term 3,000. But pick something between like 1 and 10. 6. So if you tried 6, do you see that you would have, if k is 6, wow, let's work on this. K is 6, then what would we have? We would have an x to the 6 on the bottom. Can you see that? And this would be 9 minus 6 would be 3. X squared to 3. You'd get an x to the 6 on the top. You see that they'd all cancel out, and you'd end up with no x's whatsoever. How many x's did we want? 9. We canceled out too many. Does it make sense that your next guess might be trying to pick something smaller on the bottom, so you don't cancel out as much? Amy, pick a number smaller than 6. 4. So if we chose k as 4, then you would have an x to the 4 on the bottom, right? And 9 minus 4 would be 5. X squared to the 5 would be x to the 10. If you simplified this, you would get x to the 6. And all of a sudden, someone's already figured out it has to be 3. Because it's like, you're getting closer, and it's like, okay, fine. It doesn't take you too long with guessing and checking before you figure out what has to work, okay? Sometimes on the exam they go, you have to do it algebraically. If you have to do it algebraically, then you have to work with your exponent laws. So we have x, stay with blue. We have x to the 9, and here, this would be x to the 18 minus 2k over x to the k. My exponent law for dividing is to subtract. If I subtract, I would get x to the 18 minus 3k. And just like in our logs unit, so if the bases are the same, then 9 has to equal 18 minus 3k. And 3k would equal 9, and k is equal to 3. So we do all of this work find out what k is, you now can solve the question because the question said find the term. If k is 3, we need to find k plus 1, term 4. And now we can go back to our same formula and say, I know I can find term 4. N was 9. K is 3. A was, oh, I can't remember, 3x squared. 3x squared to the 9 minus k. And B was negative 2 over x to the k. Again, we have to figure out each of these things separately. So go to your calculator. 9 choose 3. 4 will equal. This will be 84. 3 to the 6. 729. X squared to the 6 will give me x to the 12. Negative 2 cubed will be negative 8x cubed. X cubed. Did each bracket separately. First, now I can put my numbers together. Do you see that you have 84 times 729 times 8, negative 4, 8, 9, 8, 8, 8. You will have some big numbers in this unit. Don't be surprised if I get you to do an expansion and you get a number in like the billions. That can be quite normal in this unit. Do you see that x to the 12 in your numerator and an x cubed in your denominator will leave you with exactly what we wanted, an x to the 9. And you actually picked a very good guess for k to begin with because it is the last type of difficult question. The last type of difficult question is where they ask you to find the constant term. And a constant in an equation has no variables. This has no x's. And in order to get no x's, the exponent would have to be 0. Can you see that in that last example, in our first guess and check for k, you picked k as 6 and all the x's disappeared? You would have found the constant term right away in that one with guessing and checking. Okay? Do you know what happens on every single test when I ask constant term? Somebody puts up their hand and says, what does this mean? Okay? Okay, so it's officially on the video. Okay? I can't tell you what it means on the test. I can tell you, I told you you might forget this, and I made a video and I said, don't forget what constant term means. And they're like, oh, I kind of remember from the video, but I was daydreaming at that time. So constant term means that all of your x's have gone away. They've all canceled out. So a question, we'll do one. It looks like this. Find the constant term in the expansion of 5x cubed minus 2x to the 12. And notice how I put x's in both the first term and the second term of our binomial? That makes these the most difficult possible. There are some that you'll do on your pretest and in homework assignments that are going to be easier. You're going to be able to just look at your formula and figure out what k is right away. But again, we're going to write out our formula. K plus 1, n choose k, a to the n minus k, b to the k. Can you see that there would be 13 terms? I will also tell you on your test, well, you could find all 13 of them, and maybe after you simplify, one of them, you were reminded what constant term means. That wouldn't be as much fun. So we write in everything that we know. Well, we know there's going to be no x's. There's just going to be a number left for the term. We know that n is 12. We don't know k. We know that a is 5x cubed to the 12 minus k, and b is negative 2 over x to the k. And I'm not going to write it out this time, but we need to find k. Okay, I'll write it. I'll write out find k, because that's our first job. Okay? We temporarily ignore the numbers in front and just look at the exponents. So the only exponent, I'll leave it as x to the 0 to say all of your x's cancel out. We can ignore the 12, choose 6. We can ignore the 5 because that'll make a coefficient. In our numerator, do you see that you'll have an x cubed to the 12 minus k? In your denominator, you'll have an x to the k. You're only allowed 2 guesses, and then we'll do it algebraically. Pick a number for k. Someone yell out a number, any number. First guess can be totally without thinking. 8. So if k is 8, can you see that in your denominator you would have an x to the 8? And 12 minus 8 is 4. X cubed to the 4 will give you an x to the 12. This simplifies to x to the 4. We still have x's left. They didn't all cancel. Do you need the number in your denominator to be bigger or smaller? Bigger. Okay, you get one more guess. What would you like to try, Kay? 9. 9? So then you would have an x to the 9 on the bottom. 12 minus 9 is 3. X cubed to the 3. Oh, you got it. Well, not 0. Careful, right? That's not 0. That would be x to the 0. It cancels out. It's equal to 1, right? And x to the 0 is equal to 1. Again, we could do this algebraically, but you figured it out. So we found out that k is 9, which means we need to find which term? Term 9? No. We need to find, k is always 1 less than the term. We need to find term 10. So now we can go. Term 10 is going to equal, n was 12. Choose k is 9. A is 5x cubed. 12 minus 9. B was negative 2 over x. 9. Again, take your times. Figure out all 3 of these. Simplify all 3 separately first. So I go to my calculator. 12, choose 9. 220. 12 minus 9 is 3. 5 cubed is 125. X cubed gives me x to the 9. Powers of 2. Do you know what 2 to the 9 is? It's an odd number. It's going to be negative. 512 over x to the 9. Perfectly, can you see that your x to the 9s are going to simplify? That's what we wanted. We wanted a constant term, which means there's no x's. If I take 220, I multiply by 125, and then I multiply by negative 512. Negative 1, 4, 0, 8, 0, 0, 0, 0. Big number. 14,080,000. Wow. But it has no x's. This is our constant term. So those are the more difficult ones, especially the ones term containing and constant term where you have to just think about the exponent as the hint to solve for k first. Then once you have k, it becomes exactly like question number 3. We have to find a specific term. Okay? You also have to read the question carefully. Okay? This says find the constant term. Sometimes the question will say, which term is the constant term? That's much easier, because then you're done. When you find term 10, you say, it's term 10. It didn't ask me to find the constant term. But more often, right, they'll have, like in this one here, it said, find the term containing x to the 9. It didn't say which term contains x to the 9. If it said which term contains x to the 9, you could stop when you had to say it's term 4. But since it said find the term containing x to the 9, you have to find term 4 as well. Questions for practice on this one? For these ones are number 9.